right, welcome. Today's lesson is 40, area of a circle. Today we're going to talk about the formula for area of a circle, how to use it, and sectors, arcs, central angles, and the cool part is finding the area of just a portion of the circle or a sector of the circle. That's like the pizza shape, how big that area is. So area of a circle is A equals pi times radius squared, pi r squared. So we're going to find out how to use that. Find the area of a circle with a radius of 8 centimeters. So I'm a picture person, I like to draw the circle. If the radius is 8 centimeters, we just take that 8 and plug it right into our formula. So we write pi times 8 squared, which would be pi times 64, or writing the coefficient first, we would write 64 pi and then put our centimeters squared because we're in area. Now, it didn't say if we should use 3.14 for pi or 22/7 for pi or the pi button on our calculator or leaving pi as pi. So for right now, we're going to leave pi as pi. And that's the mathematician's answer. If you were an architect, engineer, or a builder, you would probably want to calculate what that pi was so you get down to the nearest square centimeter. All right, so how about this example? A circular table in the library has a diameter of 6 feet. If 4 students sit at the table, then each student has about how many square feet of space? Use 3.14 for pi, so now we know what to use for pi. We're going to do that at the very end, though. So what we have is a circular table. We've got a student sitting here, 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 and here. There's 4 students. And if they were to divide the table up evenly so that each of them had a workspace, so here's this student's workspace, here's this student's workspace, how much area is that? So what we did is we created a right angle, or more importantly, we created a fourth of a circle. So their area of workspace is 1/4 of the whole circle. So if I found the area of the whole circle, pi r squared, and took 1/4 of that, that would tell me how much area this portion is, this sector. So my radius, let's read it again. It says it's a diameter of 6 feet. So from here to here is 6 feet. Well, my formula needs radius. So my radius is going to be half of 6, or 3 feet. So I'm going to go pi times 3 squared, which is pi times 9, or 9 pi. We're supposed to use 3.14 for pi. So I'd go 9 times 3.14. And then we talked about before that I don't want the whole circle. This was the whole circle. I want 1/4 of the circle. So I'm going to do 1/4 of the whole circle. So I'm going to take that 1/4 and then I'm going to divide that answer by 4. So calculating that out, I think it came out to be like 7 something. And that's for you to type into your calculator, divide, and that'll give you your area, and we'll be in square feet. Okay. All right, so let's review a quick circumference problem. It says, oops, I lost my circle. Here it is. All right, what is the circumference of the circle? Remember, C equals 2 pi r, that's circumference equals 2 times pi times the radius, or circumference equals pi times the diameter. Well, in this case, we have the radius, so let's use this equation. We're going to plug in 6 in for the radius, 2 times pi times 6. 2 times 6 is 12 times pi. It says express the answer in terms of pi. So I'm going to leave it as 12 times pi, and my units are inches. Now again, circumference is a linear measurement. It's not an area, so linear just has singular units. The next question about the circle is the area. What's the area? So let me just move that down a little bit. The area of the circle is going to be area equals pi times radius squared. So we're going to go pi times 6 squared, or pi times 36, or we like the coefficient in front, we write 36 pi. We put our units in inches squared. It said to leave pi as pi, so I'm done. 36 pi inches squared. All right, this sprinkler question shows up a lot on the standardized tests. And a lot of students get a little bit tripped up because they're not sure what do they mean by sprinkler pattern, circular. Well, picture one of those spray heads that goes psh, 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 and it sprinkles in a whole entire circle. It keeps rotating around. So if this is the head and it sprays water out and then it rotates around, you've got a circle. So this sprinkler, it says the radius is 7 feet, and they want to know how much area of space the sprinkler waters. And they want it to the nearest foot. That means we're not going to be leaving pi as pi. We're going to be using, it gives us a little hint, use 22/7 for pi. Okay, you'll see why. Area equals pi times radius squared. My radius is 7, so I do pi times 7 squared, which is pi times 49. We like the coefficient in front, 49 times pi. And then use 22/7 for pi. Why would we do that? Because 22/7 has a 7 in it, which is compatible with 49. So we can cross cancel. 7 into 49 goes 7 times. 7 times 22 is 154. Our units are feet, feet squared. And there's our area. Okay. All right, a couple vocabulary terms. Sector. A portion of the circle that goes from the center out to the edge is called a sector. The portion of the circle that is on the edge of the circle, that's the curved part, is called an arc. So this is the arc, this is a sector. And then the angle that is created from the center out to the edges, that's called a central angle, as opposed to an angle that goes from here to here is called the inscribed angle. We'll do that in another lesson. But this one is the central angle because it goes to the center of the circle. That's how you can remember that. So here's what's fun about central angles. Sometimes they'll give you the central angle, and they'll tell you how big that central angle is, and they'll say, well, how much area would just this sector be? So again, we don't want the whole circle, we just want that portion of the circle. So we would take, first, and we find out how much of the circle is this sector? What portion of the circle? So I go, well, I know a whole circle is 360 degrees. There's my whole circle. This is part of the circle. So part of the whole is going to give me what portion of the circle. So I'm going to reduce that fraction. I see that they both are divisible by 9. That would give me 5 over 40. I can say, oh, they're both divisible by 5. That gives me 1/8. So this is 1/8 of the circle. Is 1/8 the area? No, 1/8 is the portion of the circle. I still haven't even found the area. Let's do that next. Area equals pi times radius squared. What is my radius? 4 millimeters. Pi times 4 squared, which is pi times 16, which we like the coefficient in front. So now, this is my area of the whole circle. I'll put A of the whole circle. But I want 1/8 of that. So I'm going to take 1/8 of the area of the whole circle and find 1/8 of 16 times pi. Well, here we go, compatible numbers again. 8 and 16 are compatible. It'll go in twice, so I have 1 times 2 pi, which is just 2 pi. And my units are millimeters squared. So it's like this little piece is 2 millimeters squared of area. This would be 2 millimeters squared of area. Each of those 2 millimeters, 2 millimeters, 2, 2, 2, 2. All 8 of those each have 2 millimeters. So I can, again, back up a step. The whole circle has 16 pi millimeters squared of area. Likewise, if I had half a circle, couldn't I find the area of the whole circle, cut it in half, and then I'd have the area of half the circle. So again, do I have a radius? No, but I could find it. The diameter is 16, so my radius is 8. I'm going to go area equals pi times radius squared, or pi times 8 squared, which is pi times 64. And then I'm going to cut that in half to find half of that, which is 32 pi centimeters squared. So there's half my circle. That was a really fast example. And that's the end of the lesson. You can do practice problems on 267.